Hey, all right. So our second lesson in graphing relationships is this. We're going to be talking about continuous versus discrete graphs. We've already talked about this a little bit, but it's important to truly drive it home. So continuous versus discrete relationships. Continuous means truly it continues on. There's no break in the data at all. So continuous graphs, we're going to see connected lines or curves. That should be an R, or curves. So we can see how things sort of change over time, that sort of thing. Discrete graphs are just that, are discrete, like they stop. They have points where there is no data in between them. So discrete graphs, you're going to see points, no lines connecting them. Again, when it comes to domain and range, domains that we'd like to see or ranges that we'd like to see would be in terms of inequalities. So domain and range for continuous graphs are inequalities. If we're looking at discrete graphs, our domain and range are individual points. Or numbers. So to put this in perspective, it's helpful to actually see the graphs and see scenarios that work. So a continuous example would be water pours from a tank at a rate of 5 gallons per minute. The tank begins at 40 gallons. So we would see something like this. We'd start here at 40 gallons, and for every minute that passes, we're going to see 5 gallons decrease from this tank. So after 1 minute, we're going to have 35 gallons. After 2 minutes, we're going to be at 30 gallons. After 3 minutes, we're going to be at 25. 4 minutes, we're going to be there. And while I drew points to sort of plot this line, what we know is at half a minute, there's some water that is still leaking out. No matter how many seconds are going by or how many minutes are going by, water is continually coming out of this tank. And the key word to that is water is continually coming out of that tank. So it's telling us it's a continuous graph. Another thing that I could hint to here would be temperature tends to increase or decrease over time. People traveling via speed or acceleration, that's a continuous graph. There's no discrete points in those because you're either slowing or speeding up or slowing down. Sure, you're staying the same at certain points in time, but if you went from no speed to 60 miles an hour, that increase is really awkward and you wouldn't be able to do it just in one split second. It happens over time. So even speed can be a continuous sort of graph too. Discrete graphs, we're talking about those points, that sort of thing. There's no lines that connect the dots. It would be something like this. Simon sells candles for a fundraiser. For each candle he sells, he earns $3. So he's not going to sell a half a candle. He's not going to sell a quarter of a candle. He's not going to sell slivers of candles to get pennies. That doesn't make sense. So a continuous graph doesn't make sense. But what does make sense is every candle, one candle, he gets $3. Two candles, he gets $6, and so on. So we'd want to see something like this. One candle, $3. Two candles, $6. Three candles, $9. And so we're not going to connect these dots because, again, he's not going to sell fractions of a candle. That would make no sense whatsoever to sell fractions of a candle. It's not a continuous situation. He's not going to be making pennies for parts of a candle that he's selling. So because of that, and because he sells one candle and two candles and three candles, discrete values of candles, he makes a discrete amount of money or specific amounts of money. And so therefore it is just points plotted. Okay. So have that continuous and discrete graphs. We have one more lesson or one more video for this lesson, and then you'll be able to do the must-do practice problems and try your hand at the XPath. All right, cool. Bye.